Hello and welcome to yet another installment of the Algebra 2 videos, and this is a video over section 5, which is factoring trinomials when the value, your leading coefficient, is larger than 1. This is very important. I'll be honest, I didn't learn how to really do this until I was in college, and I always struggled with it, so I'm actually pretty good at it, good at teaching it and all that, okay. So our objectives today, we want to determine if a trinomial with a leading coefficient greater than 1 is factorable, and if so, write it in factored form. Sometimes these aren't factorable. Okay, and then 2 says relate the factorization of a trinomial with a leading coefficient greater than 1 to a geometric model. So let's go ahead and talk about that geometric model right now. And what I want to do is go through how you would model something like this polynomial here. And so notice what we've got is we've got 2x squared. And so I put those 2x squareds here. We've got 5x's, okay, which go here, and then just 2 single digits. Now what you want to do is you want to create a rectangle out of this and see if we get anything. So if we put all of our x's over here, then we don't have any room for our digits. So you kind of got to play around with it for a little bit. And then what we end up finding out is that if you kind of manipulate it a little bit and get it so that you can get those 2 values in there. Okay, and then what you do is you kind of just go straight for, okay, so how many x's would go here? Okay, and you'd put 2 here. And then you'd put an x here as well to get x squared. And so x times x gives you x squared. X times x gives you x squared. Okay. X times what would give you another just x. And that would just put me a single digit right there. And then you kind of have to sit around and go, okay, well, what would I put here to give it, to make it reasonable? And you would put, x times what gives you x. X times what gives you an x. And then 1 times what gives you 1. And so you'd put a 1 here. And then the same thing would happen here. You'd put a 1 here. All right. So, and that's the idea. So then when you'd factor this, okay, so when you'd factor this, you would say that 2x squared plus 5x plus 2 is equal to, and this factor is 2 x's, okay, 2x plus 1. And then here you would have an x plus 2, okay? So you take this and you'd multiply it by x plus 2, all right? Now, if you wanted to check to see if you're right, then what you'd want to do is just FOIL this out and multiply it out. So you'd get x times 2x, so x times 2x, and so my first terms, which gives us 2x squared, okay? Take your outside terms, 2x times 2, so 2x times 2, and that's going to give you 4x. And then your inside, okay, and that's just going to give you x times 1, which just gives you 1x. And then the last one, you would just do 1 times 2, which gives you just 2, okay? And so if we added these together, and you'd add all of them together, but you'd get 2x squared. These two you can combine as like terms, and you'd get a positive 5x and then plus a 2, okay? Which matches the same thing that you've got right here. So that's the idea of using the geometric models. The only difference is that, we can't really ask that same question we did in section 4, okay? So now what I'm going to do is, show you guys, the same thing using the x method. Okay, now except for this time, the difference was that the leading coefficient in the prior one was just 1. Okay, so it was kind of an easy thing to do. So I'm going to do this using the x method here, and I'm going to rewrite my trinomial as 4x squared plus, what was that, 13x plus 3. Okay, and what I'm going to do is identify my a value, which is 4, my b value, which is 13, and my c value, which is 3. Okay, and I'm going to use this method here. And so I'm going to take a times c, which is going to, 4 times 3, which is going to give me 12. okay, and then I'm going to put my b value in the middle and just call that 13. So now the question is I want two numbers that multiply to 12 and add to 13. Okay, so same kind of concept as what we were doing, except for you have to multiply the a and the c values together to get this number here. Okay, it's not as easy as it was before. So now, if I think about that, 12 and 13, that's just going to give me 12 and 1. So I'm going to rewrite this as 12 and 1. So if I take 12 times 1, I'm going to get 12. But if I take 12 plus 1, I get 13. So now what I'm going to do is I'm going to split the middle term. And so I'm going to write this, and I'm going to kind of show you guys, how I do this. So let me rewrite my trinomial 4x squared plus 13x plus 3. And I'm going to rewrite this and split up this 13x into the sum of 12x and 1x. Okay, so I have to use these numbers to help me. So I'm going to do this. I'm going to say 4x squared, and then plus, I'm going to put a 12 here. So plus the 12x, and then plus another just single x, and then plus 3. Okay, so then what I can do, okay, because I've split this middle term, and all I've essentially done is rewrite this 13x as 12x plus an x. If I add them together, I can get back to my 13x. So now I want to group them. Okay, I'm going to group these first two terms and these last two terms, and I have to say, okay, well, what can I factor out of this? Okay, and the answer is a 4x. Okay, so I'm going to say, if I factor out a 4x, then I'm left with just a single x plus 3. Okay, and that's a good thing because that's what I've got over here. Okay, so then I've got to plus the quantity x plus 3. And now I have that common x plus 3 term that I can then factor out. Now if I factor out that x plus 3 term, okay, x plus 3, then what am I left with? And I'm left with times 4x plus 1. Okay, when you factor this out and there's no number there, there's a 1 there. Okay, and so this is factored. Okay, and some people can do this in their head really quickly, but to me, I have to have a process. So what I do know, guys, is that this is equivalent to me saying 4x squared plus 13x plus 3. And you can check that by foiling. You can always check to see if you're factored correctly if you go back and remultiply these out and if you get the same thing that you started with. Okay, so let's just do another quick practice problem. I'm going to identify my a value. So a is equal to 6, b is equal to 13, and c is equal to 6. And so what I'm going to do is I'm going to do the AC or the x method. Okay, if I take a times c, that's going to give me 36. Okay, so I've got 36 here. And then I've got my b value, which is 13. Okay, now the question is, what two numbers multiply to 36 but also add to 13? Okay, and it may take you a little bit to think about it, but those numbers is going to be 9 and 4. Okay, 9 times 4 gives me 36, and then 9 plus 4 gives me 13. So what I'm going to do is I'm going to take my trinomial 6x squared plus 13x plus 6, and I'm going to split up this 13x. Okay, and I'm going to use 9 and 4 to do that. So I've got 6x squared, and I'm going to do plus a 9x, and then plus a 4x, and then plus 6. Okay, now what I want to do is I want to sit there and go, okay, well, what can I want to group these. I'm going to group the 6x squared and the 9x. I'm going to group the 4x and the 6. Okay, and so what can I factor out of the 6x squared plus 9x? And that's going to give me, I can factor out what, a 3x out of that? So if I factor out a 3x, then I'm left with 2x plus 3. Okay, left with 2x plus 3. All right, now I can also factor out a 2 out of here. And when I factor out a 2, all right, I'm left with a 2x plus 3. So I have a common 2x plus 3, so this is going to work. Okay, so I have those that I can factor out, and if I factor out a 2x plus 3, okay, then I'm left with a 3x plus 2, and that's it, and that's my answer. That's in factored form, okay? So, it's a pretty easy method to do. I think it is. I think it's pretty easy. It's kind of whatever you guys think you should do, but, let's try the similar ones, and let's use the box method, okay? And so, okay. If I take the box method, what I want to do is I want to, and this is kind of a trial by error type thing, but what I want to do is this. I'm going to make the box here like that, and let's give it 4 spaces. Okay, remember the first term, the 6x squared, goes here. Okay, and the last term, the negative 4, goes down here. Okay, now the question is sitting here going, okay, what 2 things can I multiply together to give me a 6x squared? Okay, so the 2 numbers that I can multiply to get 6 would be 2 and 3, and then we'll just attach an x on them. So I'm just going to put a 2x here and a 3x here. Doesn't matter. I could flip-flop these. Doesn't matter where I put them. But then the question is, all right, well, what are 2 numbers that multiply to negative 4? Okay, and this is the tricky part, because now what I want to do is, kind of sit there and go, well, what's going to go here? So it's kind of tricky. So let's do this. Let's just say that we got a negative 2 and a positive 2. Okay. Now what I'd want to do here is I'd want to say, all right, well, let's take the negative 2 times the 3x, and that's going to give me a negative 6x. And then if I take the 2 and times the 2x, then that's going to give me a, what do we get there? That's just a positive 4x, so negative 6x and a 4x. Now if I add these together, I end up getting a 2x, or a negative 2x. And that's not the negative 5x. So what I've done is this doesn't really work. Okay, I'm not getting what I had. So now let's try something else. Okay, and I haven't done this problem, so I don't really know. So you're watching me go through this and make mistakes. So we have to do this again. Okay, so no. So it doesn't work. Not working. All right, so let's try again. So let's do this. Let's do the same thing. Make our box. And I got to put the 6x squared here and the negative 4 down here. And so, the thing that I thought about was, well, what if I put the positive 2 here and the negative 2 here? What would happen if and you can kind of just switch those around. As long as these 2 numbers multiply to this, then it's okay. So I got 2 and 3x would give me positive 6x. And then 2x and negative 2 would give me negative 4x. And still that would just give me a positive 2x. That's not really working to our advantage right now. So now the thing of it is all right, well, let's take a look. Let's try something else. Let's keep the same 3x over here and then a 2x over here. And then instead of using the 2's, let's use 1 and negative 4. And let's try this. Okay, let's do a negative 4 here and a positive 1 here. Okay, so 2x plus 1 and 3x minus 4. Now if I take negative 4 times 2x, it's going to give me a negative 8x. And if I take a 3x times a 1, that's going to give me 3x. So if I add these together, do I get negative 5? And the answer is yes. So I get a negative 5. So then, okay, if I factor this, and guys, it just takes some just keep thinking about it and keep working at it. If that wouldn't have worked, then I would have changed this to like a 6 and a 1. Okay, but let's go ahead and let's rewrite this as you've got 6x squared minus 5x minus 4 is equal to 2x plus 1. So 2x plus 1 times 3x minus 4. Okay, and so you just I recommend the box method. I think it's pretty easy. So let's do it again. Let's just kind of practice this, and let me zoom in here on this. We want to factor this trinomial. And so let's go ahead and draw our little box, okay? And then what I have here is, okay, I've got 7 and an x squared and then a negative 4. Okay, so now this is where it gets kind of, a little bit easier because like the only two numbers that multiply to 7 is going to be 1 and 7. So this is just going to be 7x and a single x, okay? And then two numbers that, add to 4 or multiply to 4 would be negative 2. And let me put the negative 2 up here and then the positive 2 down here. And so what I see is this. Actually, that's not going to work. I already know it's not going to. Well, let's just go through it anyway and show you that it's not going to work. Okay, if I take negative 2 times 7x, that's going to give me negative 14x. Okay, and then if I take 2 times x here, it's going to give me positive 2x. If I add these together, this is going to give me negative 12x, which is not negative 3x. So no, can't do it, can't have it. So let's try something else. All right, let's do another box method. So let me draw another box here, and let me put the 7x squared there and the negative 4 there. And so do the same thing. Let me put the 7x here and the x. Now, let's use 1 and 4, okay? And I'm going to put the 1 here, all right? And I'm going to make this a negative 1, okay? So that when I multiply these together, I get negative 7x, okay? And then if I'm going to put a plus 4 here, then I get 4x, okay? And if I take 4x plus negative 7x, that's going to give me negative 3x, which is the same thing I had here. So the factored form of 7x squared minus 3x minus 4 is going to be 7x plus 4. So 7x plus 4, and then just times an x minus 1 factor, okay? And that's what we've got. So you can always check to see if you can multiply it through, okay? So then, okay, and then we have this thing where it's called recognizing a prime polynomial. Not all of these polynomials are factorable. Okay, so let's do this. Let's do the x method on this, and let's take 3 times 5, which gives me 15, and then put negative 4 down here. Now the question is, what two numbers multiply to 15, yet add to negative 4. Okay, so those two numbers would have to be negative. So, you think about it. Take the factors of 15. You've got 1, and you've got 15, and then you've got 3, and you've got 5. Okay? Now, these would have to be both negative. So if you took negative 3 and negative 5, that's going to add together to give you negative 8. Okay, that doesn't really work. Even if you took negative 1 and 15, they give you negative 17. So that doesn't work. So sometimes, if you're trying to get this negative 4, okay, so you're not getting 4, okay, then it's not factorable. Not getting negative 4, then it's not going to be factorable. Okay, it's a prime polynomial. Okay, whereas here, okay, if you had, say, something like this, you take 2 and you multiply it by 3, that gives you 6. So you've got two numbers that multiply to 6 but add to negative 7, okay, and that's just going to be negative 1 and negative 6. So when you get those numbers here, then you can factor it. It's factorable, all right? But sometimes, you can't factor them, and you've just got these prime polynomials, and it's kind of tough. So, all right. So that's all I have for this video. Again, guys, this takes practice. So I'm trying to make this as easy as possible for you. But, again, just get started on your assignments, and we will see you soon. Talk to you later. Thanks. Bye.